Good morning, everybody. So I keep catching little mistakes when I'm talking off the cuff. So this is the third time making this video. So we are dealing with power functions and polynomial functions. Power functions are things or functions that look like 2x to the fourth, or 2x to the 1/2 power, or 3x to the 1/4 power. The 3 is the coefficient, the 2, the coefficient. The power is the real number exponent. And if you see something like 2x to the 1/2, you might see it as 2 times the square root of x. This would be 3 times the 4th root of x. And just kind of think of this index here as tucking up underneath the exponent on the x. And since we don't write the 2 typically with the square root, you have to realize and remember that there's a 2 there, and that just tucks up underneath. And you can have 1x to the 0. That would be 1. It's called the constant function. You might see a 1 over x, which could also be written as x to the -1, and I put that right there as well. Now, difference between a power function and a polynomial function. A polynomial function has basically multiple power functions pushed together, added together, and they call them terms. So we've got a term, we've got a term, we've got a term. Nice things about power functions and polynomial functions. They are continuous wherever they're defined. And if you have a polynomial function, they are defined from negative infinity to positive infinity. Remember, polynomials are a little bit more specific than a power function. Polynomials have nice powers. So these powers are positive whole numbers, okay? Not fractional, because then you get something with radicals, and then your domains start to get modified, okay? Now, if you have an even powered function, and so this would be like x squared or x to the 4th. It's going to start high and it's going to end high. It's going to look like a happy face, okay? And its end behavior is going off to the infinities. If the coefficient on these is negative, so you have like a negative x to the 4th kind of thing, like a negative 2x to the 4th, it's going to look like a frowny face. It's mad, okay? So you get this frowny face going on. If you have an odd powered function and it's positive, so think about it as an upward sloping line. It starts low and it ends high, okay? Starts low, ends high. If you put a negative in front, like a -2, it's going to start high and it's going to end low. Whoops, start high and end low. All right. Now, what's interesting is when you start looking at polynomial functions, most of the stuff that we look at is around the origin, but the end behavior is still significant. And when you start dealing with large values or very, very, very small values, and what I mean by that is positive infinity or negative infinity, the x squared begins to dominate. If I'm squaring infinity, it's massive. And if I'm multiplying 4 by infinity, it's not as massive. It's a little hard to explain, but sometimes you get statements that are along the lines of, where in infinity are you? And you're much farther along in infinity when you have x squared than you are when you have x. So what ends up occurring is this sort of drops off, becomes less and less important, and the x squared, the 3x squared, becomes powerful. And so as we go to the ends, to the extremes, to the positive infinity, to the negative infinity, this polynomial function's end behavior is dominated by this. So this is the end behavior, okay? Now, I'd made the comment that we're much more concerned about the origin and what's going on around the origin. Well, if you have a function, let me do this, a polynomial function, and you have 3x to the 4th plus 3x squared plus 1. You have terms. You have three terms. Terms are formed by multiplication and division, and they're separated by additions and subtractions. So this is a trinomial. That's what you do if you're not hungry. Trinomial, haha, anyways. So you have 3x to the fourth, you have 3x squared, and you have 1. The degree of each of these terms is dictated by the degree of the exponent. So the degree of this first term is 4, the degree of this is 2, and the degree of this is 0. Now, you have to talk about the degree of the polynomial. The degree of the polynomial is the degree of the term that has the highest degree. And so the comment then is the end behavior is going to act like this. Now, this also tells us how many potential roots we have, as well as how many turning points we can have. So this 4, we could have up to 4 real roots, okay? We could have 3 turning points. So if I were to draw a 4th power, and notice it is positive, so it's going to open up. It could look something like this, where you have this sort of, there we go, touches and touches. So we get these roots, or these x-intercepts. So that's how many possible roots we have. Well, if we maximize our number of roots, we have 3 turning points. So the phrase goes, you take your highest power, like the 4, that's your potential number of roots. Okay, so you could have 4 or less. And then 4 minus 1 is the maximum number of turning points you could have. And a turning point is there, or there. Okay, so I'm going to tackle number 25 in section 5.2. I've got a minute. It says find the intercepts of the function. Okay, so you have f of t is equal to 2 times t minus 1, t plus 2, and then t minus 3. All right, so we're going to use the zero product property. A root occurs when our y value is 0. So in the ordered pair, that's something 0. So we're going to take that 0 and we're going to plug that in there. So we have 0 is equal to 2 times t minus 1 times t plus 2 times t minus 3. Oops, that's a 3. Well, the zero product property says if you have some things that multiply to 0, at least one of them has to be 0. So you put each of the factors equal to 0. And then you solve. So they always pop out as their opposite. So this is going to be t equals 1, t equals negative 2, and this is going to be t equals 3. And what about this? Mathematical nonsense. Because you really could have at the beginning divided both sides by 2 and it would have canceled out. So it's irrelevant. Okay, so your roots would be 1, negative 2, and 3. And your factors lead you to your roots. Now we'll learn some other ways to deal with that. All right, hopefully that's good. I'll talk to you later.